test.
Maybe not sync.
Well, can you hear us, Dale?
I can hear you. Can you hear me?
Yes.
Ah, perfect.
That should be good.
All right. Is everyone ready to get started?
Yeah, thumbs up.
All right. If you're excited about learning how to codify acceptance tests, say woohoo really loud. All right. It's okay, Taz. You can do it.
Maybe later I'll do it.
She's doing it on the inside. I can see it. So, as usual, we're going to start with a little icebreaker. Everyone go on over to Minty.
Which one do you pick?
I feel like one of these is very specific.
You think? We got 3 voters.
Sounds good until the kids don't see keyboard.
6, 7, 10, woohoo. 15, wow. There's more people on the call than I thought there were. 19. Okay, did anyone have a problem accessing Menti or anything like that? Awesome. So it looks like most people, if they were stuck in an infinite loop, you'd want to be debugging code in a room full of kittens. Someone else said that. So, yeah, good for you guys. So you're probably asking, what does that have to do with codifying unit tests? Absolutely nothing. But now that I have your attention and I know that you can use Menti correctly, let's talk about what we're going to talk about today. First, probably the first 15 to 20 minutes is just going to be review. It's going to be review over Kate's session last week. Who remembers that? Pretty awesome. Then we're going to do a review over my original test-driven development workshop I did. I don't know, Nick probably knows when I did it. It was a long time ago. Was everyone pretty well present for that? Okay.
I think everybody except for like our random guys.
Yeah.
Anybody that wasn't still should have got it.
But even if you didn't attend that lecture, it'll be a good review for you. Then we're going to talk about the differences between TDD and BDD very briefly. Then we're actually going to get into acceptance tests. We're going to talk about Gherkin. Does anyone know what Gherkin is?
Small pickle.
There you go. Close enough. If you don't know what Gherkin is in a software context, you will by the end of this. And then we're going to do a pretty awesome demo. Who's ready to get going? You got to yell, woohoo! There you go. Taz, you can do it this time. Okay, so we're going to start out with a review from Kate's section. We just got 3 quick questions. What are the origins of acceptance testing? Got a few questions, answers trickling in. All right. Looks like most people think it's lean manufacturing from Japan in the 50s. Are you ready to see the answer? Extreme programming. There you go. I guarantee you that's Jonas that did that. Yeah, so does anyone want to recap that? Does anyone remember from Kate's session? Is Kate here? Kate's not here. I won't tell Kate that you got her question. Any thoughts on that? Who here knows what extreme programming is? All right, someone tell me what extreme programming is.
Extreme programming is a set of methodologies to improve software development, that focuses on communication among people, as well as using test-driven development.
Very good. I like it. All right, let's go to the next review question. What is not a challenge of user acceptance testing? New requirements for stakeholders. Looks like people are really leaning on new requirements from stakeholders. All right, who's ready to see the correct answer? Identify key issues before release. So it's what is not a challenge. I think that may have been what tripped some people up. Somebody want to talk about this? Who are the people that answered identify key issues before release? Dane.
Yeah, I put this one because you're identifying your key issues well before you get to acceptance testing. So it's not uncommon for stakeholders to see a product or see something halfway through and want to add something to that scope. So that was the key difference for me, is just the timing of where user acceptance testing is compared with the timing of when you would be doing those two activities.
Awesome. Yeah, Dane gets a gold star. Next question. When does a design review happen in the story life cycle? Like 2/3 are leaning on before a story gets passed to an engineer, 1/3 after a story has been reviewed by another engineer. Who's ready to see the answer? All right, the answer is number 6. 1/3 of you got it right. After a story has been code reviewed by another engineer. So who answered this correctly and wants to talk a little bit? I can't see people's hands. The screen's too small.
Ian does.
All right, Ian.
All right, yeah, I can talk about this. So design reviews happening after the story's been code reviewed by another engineer, because usually, in a ticket, you'll have the Figma link, and then one of the engineers, for example, I might pull a ticket link, I might code it up, and then I would have another engineer, for example, Cody, review my code and make sure that it's all good, my code doesn't look like garbage, there's not many comments, it's succinct, makes sense, all the tests are there, all that type of stuff. But then before I would actually push that to Maine, I would have to get a design review and say, hey, Caden, like, does this look okay? Caden might say, hey, what are you doing? Like, the background here is supposed to be purple and that button is supposed to be yellow. And then I would have to go back and make sure that what I coded actually matches up with the intended design.
Cool. Does anybody got anything to add?
It's not a review of the design, it's the designer reviewing the code to make sure it looks like the design. Right?
I'm sorry, I couldn't.
I have to go close to yell or
Okay.
yell.
It's not technically a review of the design, like would be implied by that first answer. It's a review of the code by the designer.
Yes, correct. Mhm. All right, so now let's talk about the testing pyramid. Who remembers the testing pyramid? All right, who loves the testing pyramid? There you go. I think I got 3 people. Okay, you will love it by the time this is over. So the reason I'm going over the testing pyramid again is because in the original lecture, I hit on it really fast, and I think I missed some of the main points of it. So the intention of this next 5 to 10 minutes is to get you really, I want you to have a visceral connection with the testing pyramid and why we use it. The testing pyramid is one of those concepts in software engineering that if you type that into a search engine, you will get thousands of responses, and most of them are really specifying some dogmatic view of the testing pyramid. So what I want to provide here is a much more pragmatic view and why we use the testing pyramid, not just a bunch of rules to comply with the test pyramid. We're going to talk about why we use it. So what the test pyramid is, it outlines the optimal balance of different types of tests. So why do we fragment the test suite in the first place? I think everyone here who's in Swarm or RapidRef anyway sees that we have tests split up into 2 different suites. We have them in unit tests and we have service tests or integration tests. Consider service and integration the same word for the purposes of this presentation. So has anyone ever wondered why we did that? Why is that important? So I'm going to tell you, it is speed. There's a lot of content, like I said, out there that will give you all of these dogmatic rules to follow. But the original reason why we started breaking up these, we started doing this in mid-2000, was because of speed. Computers were slower back then, right? So the point of unit testing at the bottom of your pyramid is you should be able to run all of your unit tests within seconds. If your entire unit test suite does not run in seconds, you need to think about reworking some stuff. So unit tests are small, discrete tests. And after you run your unit test suite, you should have about a 90% confidence level that all of your code is correct. Now, the middle layer there, service test, they run in minutes. And these are bigger, more expensive tests. You should run them probably right before check-in, and they should get you to about a 95% confidence level. And then the final thing is UI test. And this is something we haven't done a lot here at Wavelength, but maybe after today we will. So UI tests are really end-to-end tests that have fidelity with the production system, and they can take hours to run. I actually worked on a project in Arizona where they were doing flight simulations, and the UI test would actually take 3.5 weeks to run. So you would actually have a bunch more tickets done by the time a single UI run happens. So obviously it wouldn't make sense to run them constantly while you were trying to work. So this is why these are sort of a separate thing. They're also very expensive. Like the further up the pyramid you go, the more costly it is. Why spend $1 million when you can spend 100,000 is basically the thought here, right? If you can get the same thing with much cheaper tests, why wouldn't you? The things that drive up the cost of the test are one, the testing implements themselves. Two, it's just time. Engineers are expensive. So let's look at the very bottom of the pyramid. These are unit tests. I think all the engineers in here have written a unit test, as far as I know. If you're working on Swarm or Rapid Ref, I'm not sure what everyone else is working on, but I think most of you has done this. Now, the point of a unit test is it should be isolated to a single process, right? So this is things that you don't need multiple threads or anything like that. These will run really quick. They're discrete units of testing. They should run very fast. They should be very simple to understand. They typically require mocks, stubs, that sort of thing, and they should run in seconds. So remember, the desired outcome is fast and cheap verification at 90% confidence level. If you can get that without being isolated to a single process, go for it, right? It's not that important. The speed is what's important. But typically, when you think of a unit test, that's what you see. A typical example of a unit test, imagine this top bit of code is in one file, and this bottom bit of code is in a different file. And obviously, it's about, we're writing a test for Plato's theory of forms. Just seemed fitting. So the thing to notice here is that this test is acting on a pure function. Somebody define pure function for me.
That has, I'm sorry.
Sorry, I didn't hear you.
No, like, dependencies, there's like nothing. There's no other functions in there.
Close. So a pure function will always return the same output given the same input. It has no, it doesn't rely on any global variables. It doesn't rely on external state like a database. It doesn't rely on any of that. It's just logic. I give you this value, it modifies it and returns it back, right? Or modifies it, it's a bad way to say it. It does some calculations and returns that value back. So the bulk of your code should be made up of these pure functions like this, right? So if you have something that relies on global state, instead of having it access that global state from within your function, make your function pure. Pass the state variable that you want in there. Does that make sense? Yeah. So the bulk of your test should be like this. Now, anyone who's lived in the real world knows that if you had code that actually doesn't have any side effects, it wouldn't do anything useful, right? So you actually have to have a side effect at some point, but the bulk of your code should be on this at the bottom of the pyramid. Integration tests, on the other hand, these are one level up or service tests. This is the middle of the pyramid. Instead of being isolated to a single server or a single process, they're isolated to a single server. Now, I'll say over time, if you read Kent Beck's original book on automated testing or test-driven design, stuff by Ward Cunningham and stuff, the definition of single server has changed over time because now we have containerization. Although we had containerization back in 2007 with LXC containers, no one was really using it, right? It wasn't a popular thing and it was really hard to use. But now containers are really easy to spin up. So you can do a lot more on a single server, although technically, right, logically, you have more than one server. You still have a single server. And as long as you can do this fairly quickly, it's fine to call this an integration test. So the point of an integration test should be to verify data flow and interactions between multiple things. So if you got a back end and your front end, right, your unit test would test those in isolation. Your integration test would test how those two come together and make sure the interfaces defined by the back end line up to the interfaces defined in the front end, so on and so forth. So as we remember, the desired outcome is verifying component interactions at 95% confidence level. If you pass this test, you should be 95% confident that it's going to work. And I think everyone has pretty much seen the difference between an integration and a unit test. I think you will hear me bark at people sometimes if you write a unit test that actually has to reach out to a Docker container, because you don't want to have Docker containers, or actually Podman containers sometimes. You don't want to have them have to be running to run your unit test, because they got to be fast. That makes it slow. Any questions about that? All right. So here's an example of a integration test. Notice that we are actually importing Express. We are reaching out. This is our server up here that's defining a route, a lot of external stuff, right? And we have our test. We're using super test here. It's like, I think that's what you guys are using on RapidRef too, right? I know we're using it on Swarm. Yeah, I thought you were using super test. So super test is just something that will stand up your app. Now, when this runs, it is testing more than just this bit right here, because it's acting on the app externally. It's testing all your routing. It's testing all your middleware. It's testing all of that. All of that is set up. So this is an integration test because it's doing multiple things, right? So it's just, in theory, it will run slower. Question: what if you can get a test like this to run super fast? Where does it belong? Say you have a test that is maybe not reaching out to a database, but it is verifying a contract between two pieces of code, and it runs super fast. Where would you put that?
Would it be the unit tests?
Yeah, honestly, you could put it either place, whatever makes you the most comfortable, right? But generally, if it runs super fast, even though it is testing multiple things, you could still throw it in unit test. All right, so the top of the pyramid is what we haven't done much of at Wavelength, and hopefully by the end of this, we'll do a lot more of. So end-to-end tests require multiple servers. They're painfully slow, but the thing is they have very high fidelity with the production system. They can run into hours, right? So a UI test is ran as an external user. A UI test should not have any knowledge whatsoever of what database you're using, even what technology stack you're using. It should know nothing. It should know as much as an end user will know when they're going to use your application. Now that is a bit, that's an ideal. Like sometimes you have to do something like say, I need this setting in the database to, or this amount of data in the database to test some certain interaction, right? So it's not 100% true, but that's what you should strive for, is making a UI test or an end-to-end test should be completely separated from the code in its own repository, doing its sort of own thing. They shouldn't really know about each other. So this is an example of a UI test or an end-to-end test. And you notice that these tests get bigger and bigger as we're going here. Notice this is using something called Selenium WebDriver. This is just one thing you can use. There's tons of ways to do UI tests. The only thing I'm going to caution you on is don't fall into the trap of buying those huge UI testing frameworks, because they're all garbage. Not to speak too frankly, but they really are. So what this is doing is actually spinning up a browser. Like if you look right here, the driver is actually creating an instance of the Chrome browser, right? And from within the Chrome browser, it will go out, it will navigate to a page, it will find elements on the page, and it will click things, it will move things just like it would, just like an end user would. This is basically you're setting up these tests, you're running them incomplete. You could stand up your production system and run these tests against it. I wouldn't do it because it, you may run into some performance issues for your real users, but that's all it is. Does it make sense how these work? So the point of this sort of UI test is so that everything's working end to end without fail. Has anyone ever done any testing like this before? Ian has, Austin has.
Yep, I had used Cypress before, but it seems pretty similar to the same concept as Selenium.
I'm pretty sure that Cypress was forked from Selenium, but I could be wrong on that.
That would make sense.
Yeah. So do you guys understand why this type of testing would be important? Taz, why is it important to have a complete end-to-end test?
I'm very new to testing, so I don't have any idea about this. So I don't want to be.
No worries. I didn't mean to put you on the spot. It's just you're a square I can actually see. So let's see. Ryan, where are you at? Tell me why this type of testing is important.
It's important because it mimics the user, and if there's any like dead routes or anything, it'll find it through testing, so you don't take it live, and it finds that where the actual user's interacting with it.
Yeah, I didn't quite hear him.
You might get close to the owl.
But that's all right. So I think I'll summarize what I think I heard. And you said, so you can find errors before the user does. Is that basically what you said?
Yeah, that's the gist of it.
Okay, perfect. Yeah, that's exactly right. This is the only way of doing an automated test that works as a production unit. Like if you're doing things in a different environment with different settings, right? Like you can get different results. This should have very high fidelity and really drive home that concept. All right, any questions about that? So go ahead.
So I remember in the SIL, you showed us some tool that does UI testing with like a visual like interface, like with a GUI. It actually shows like it clicking through all the elements and stuff. What was that tool?
I believe it was Selenium. It might have been
Okay.
Cypress. I don't know. There's so many of them out there. But we're going to see another example of that shortly. So the other thing I want to say, and I'm starting to get behind here, so I'm going to do this in 1 minute. TDD versus BDD. One of my biggest pet peeves is when someone just defines a new term that really means the same thing the old term did. So like if you're doing TDD the way like you probably just should be doing it, it sort of covers the BDD angle, right? But BDD is just it's sort of the same thing from a different lens. BDD is usually associated with different tools, right? So when you're using BDD, it's usually things like natural language, Gherkin, things like that. And when you're doing TDD, it's more like code type of things, right? Like for developers. Now, if you have a really good system in place, you should probably be doing both TDD and BDD, depending on your vantage point. But they're really sort of the same thing. If you go out and you read a book on BDD, you'll probably learn a lot of TDD. Read a book on TDD, you'll learn a lot of BDD. So they're both sort of a write your test first and maintain a suite of automated tests to do your thing. The difference comes in is sort of slightly a perspective. So BDD concentrates on the interaction of the user with your app, like what behaviors are they going to have, where TDD sort of concentrates on the on the actual act code itself, making it more modular and things like that. So and I'll say, like, there's a lot of marketing around these concepts. If you go out there and someone's teaching a BDD class, they will be like, hey, TDD is the old way to do it, and TDD people will say BDDs people are stoned, you know, whatever. Don't get caught up in the marketing hype. They're both just tools. Any questions about that? No one's going to say they do BDD now, because we'll all think you're stoned. All right. So the next question, let's run over back to Menti. When you think about acceptance tests, and this is acceptance tests as the way that Kate defined them in the last workshop, where do acceptance tests fit into this? Very good. They are end-to-end tests. Looks like most people, that's people still voting. I probably should have waited a couple minutes for you to answer. But yes, acceptance tests are just end-to-end tests. There's a few notable differences. Technically, end-to-end test, an end-to-end test is usually specified by an engineer, whereas an acceptance test is specified by a product manager or a stakeholder of that sort. An end-to-end test is usually used to validate non-functional requirements. Can someone define non-functional requirement for me? Who do I see back there? Is that Joseph? Yeah, what's a non-functional requirement? I didn't hear him. Someone summarize for me.
Requirement that non-functional.
Close enough. I'll take that as a correct answer. So a non-functional requirement is things like response times, things or uptime, things like that. Things that don't really correspond to an actual behavior of the user, right? If a user comes and makes a request from your site, they don't really get to experience the number of requests per second it's having, right? So those are non-functional requirements, where functional requirements have to do with actual sort of linear, I do this, I should get this. So acceptance tests are usually around the definition of done for a feature or the story. Acceptance end-to-end tests are usually for developer documentation, and end-to-end tests are for full team documentation. So the desired outcome of acceptance tests is for non-technical team members to write precise executable acceptance criteria. And I think the key word there is executable. Right now, I don't want any project manager to get excited. You will be writing code, but it's a specific type of code, right? So you're not going to have to worry about it. Can anyone tell me why having executable tests are important? Why is that important? As opposed to just regular documentation.
But you can do it more than once easily.
Yep, that's one reason. Specifically around documentation, why is executable documentation better than just prose?
So if a specific test fails, you can see the exact user story that was tied to.
Exactly. But there's one more thing that's really important. Code is the only thing that can't lie to you. Remember this. if you take nothing else away from this workshop, this is the quote that I want you to have. Code is the only thing that cannot lie to you. If you have prose documentation and something changes, that documentation is lying to you. The GUI will always lie to you. But most importantly, if your tests are codified and you're forced to run them and execute them, they can't lie to you, right? They have to represent reality. So you're never in a situation where you're going and reading documentation that doesn't align with reality because it's a liar. Make sense? Cool. Yeah, here's an example of a codified acceptance test. We'll talk more about this, but notice it has a feature, a scenario, given, when, then. Does this look very familiar, Dane, to the way that you just define stories now? All right, all you product managers, does this look like code you can probably write pretty easily?
Yes.
Very good. I love it. If you'd have said no, I'd have thrown you out. So who knows what this language is here? What is this syntax? What is it, Ian?
Here, like, oh.
I heard another answer. Did everyone say Gherkin? All right, this is Gherkin. What is Gherkin? Gherkin is a language. So it's important to distinguish a language from other types of software. So all a language is just syntax and semantics. It's just like the English language, right? It's just a symbols, strings that you're allowed to assemble together in different configurations. The reason why this is important is because you can have multiple separate compilers and parsers that can work on the Gherkin language. So all the way back in 2003, the first BDD tool was RBehave, and it was a Ruby tool. In 2008, it got updated for Ruby. So almost all of the beginnings of Gherkin and Cucumber, which is the tool that people use to compile Gherkin, all of the early ones were for Ruby. But nowadays you can get there's Cucumber for JavaScript, which we'll be using, or TypeScript. There is RSpec, which is a compiler for .NET to use this Gherkin syntax. So the main thing that I want you to take away here is that Gherkin is just a syntax, and you can compile it and parse it with many different parsers. If you don't know how to make a compiler or a parser, you're in luck, because the demo today has an example embedded into it. So let's look at this Gherkin a little bit closer. Up here at the top, you have a feature, and this is just free text. It can be anything you want. Right now, we're looking at Schrodinger's UI. The scenario is a specific use case of a feature. And again, this is just prose. You can put whatever you want to in there, and it will compile. The important thing is this given, when, then, and but. These are steps. So the code that you, when you put one of these, given, when, then, the text that you put after it will get attached to code. Who wants to see an example of this in action? All right, let's do it. So now we are going to share. Can everyone see my code screen? Should be looking. Is everyone good? Okay. This is Vim. It's the only valid code editor. I don't care what anyone says. I'm not about dogmatism unless it comes to Vim. You should only be using Vim. Okay, so let's look at how one of these features might work. This is, you know what? I forgot to show you our application, which I think I made this mistake when I was going through my dry run too. So shame on me. Is everyone looking at this useless expression parser? So
Yeah.
all this is a simple website that you can type in some expressions, times 5 = 2, and see the result of them. Simple enough. And specifically, the reason why I did this expression parser is so you guys can go out and look at that code and see how it is that you take a string and turn that into executable code. That's not really part of this, but just so you understand how the Gherkin language is working will be exactly like this. So let's look at the code and the test. So we look at our calculator evaluation, our code. We have a feature and then just some text about the feature. We have a scenario evaluating a valid expression. Given I am on the calculator page, when I input the expression 5.3 or 5 + 3, and I press the evaluate button, then I should see the result 8. Remember these strings, right? Now, if we go up and look at step definitions, and don't worry about trying to memorize all this, I'm just trying to show you how it works, right? We import given, when, then from Cucumber, and we actually create code that executes based on that, on them steps. So given I am on the calculator page, you're going to open the browser to that page. When I input an expression, and notice I have a variable there for a string, that means that the product management can put whatever expression they want inside that string, okay? So we go out, we grab the expression, and we set the value. When I press the evaluate button, we're just pressing the evaluate button. Then I should see the result. We're just going out and looking and seeing what's on the page. Does that make sense to all the engineers? Like I say, you don't have to memorize the syntax, but this is basically what happens, right? Your product manager will check in code that looks like this, and then you will write attach code to it that looks like this. So now, if I come over and look at this code, I run npm test, what it's actually doing is spinning up the Chrome browser. I've got this application stood up, as you can see, and it is going out and it is running tests against that instance. And look at how the test documentation looks. We'll look at these front ends. Calculator evaluation. As a user, I want to evaluate mathematical expressions so I can find the result of my calculation. Evaluating a value expression, right? Given, when, then. These all pass, right? So let's say that I come over here. Now, this gives you a lot of power as a project manager. What if you want this to be, if you wanted this to equal 9? npm test. Now, as a developer, I can come in here and I can run this test. Didn't have to change any code because I already had the steps defined. And I can see I have a failure. I know exactly what step that it failed on. The other thing that I can do as a project manager is, let's say there's some scenario here that I don't know whether it's working right or not. I can come in here, 5 - 3 should equal 2, right? Without writing any other code at all, the project manager has the ability to come in here, modify this file, run the test, and see that the new code that I specified automatically runs, and that's codified forever. So let's talk about how this works. Oh, I just got a message on my phone from Clayton. Apparently he's already read all this code, and he's pretty sure that he can make that he can write some Gherkin. And I just got a message from Ian too that says he thinks he can help Clayton. So this is totally unexpected. I had no idea this was going to happen, but I'm to keep in flow. We'll just do it. Let's let him try. Give him a round of applause here, right? Let's pump them up. Let's see if they could do this.
All right. I'm about to share my screen here. All right, y'all should be seeing my screen. All right, so as we can see, we've been working on this useless expression parser here. As Dale showed before, if I do 1 + 1, for example, we can say, hey, the result's 2. So that's pretty cool. But for example,
Yeah, so I think I have a user case where we would need to use exponents. So what happens if we use this, use the useless expression parser to see what 5 to the second is?
you mean,
Oh, no, it doesn't work. So now, since we're using Gherkin and we dumbed it down enough that any PM can do it, we can just go into. Found it.
all right.
All right, so I have this user case that doesn't work. What am I gonna do? I need to go into the right file first.
Should be, features, evaluation.
All right. And then I'm gonna cheat and make this easier on myself, so I don't have to type everything out all over again. Let's make it look pretty. All right, so given I have the expression in 5 caret 2, when I send the expression in the back end, I should get the result. If I can type result 25. Cool. Save that. But I wrote that part, which as you can see, we didn't change the code yet, so it still doesn't work. So now I call Ian. Ian, I wrote a thing, but it doesn't work.
Oh, hey, like, I saw you wrote this thing, but it doesn't work. So, I'll be in here. So as you can see, I'm in my test folder here. So if I run npm test. As you can see, and then tests take a little more time. All right, we can see the Chrome driver popping up here, running through all of our tests. And if we go back, I see we have one failed because of the new test that Clayton wrote. I see assertion error up here. We expected undefined to equal 25. And we can see right here, incorrect expression error, that we should get the result 25. We send that 5 caret 2 expression to the back end. So, all right, so I in this case will probably need to write some new code. So if I go into my source and into my, sorry, that is fine. Sorry, trying to find the correct place. So I want to be in server. There we go. I want to be in tokenizer. All right, so here we have some regex expressions we're looking at, and we notice that we don't have a caret in here yet. So I think what we're going to want to do. Sorry about that. And what we're going to want to do is we want to include the ability to parse a caret character. Then I think we have one more thing we have to do. We want to go to our parser here, and we notice we have some different cases related to operands. So I think we want a new case here for the caret. So going to copy one of our other cases and paste it. And I will also format correctly. All right, so if our case is this right here, we don't want an error. Instead, we want to return left value to the power of right value. And TypeScript, that syntax just looks a little like that. All right. So then we are going to run our tests again and see what happens. All right, and if we go back, it would help if I actually restarted the server. That would probably be a useful thing to do. All right. Now, if we npm start and restart server. All right, so our useless expression parts are back up here. And then if we npm test. All right, you see that all our tests are now passing. If I go over to my useless expression parser, there we go, and do a 5.2, we get 25. And yeah, that's an example of how the PM and dev can coordinate using Gherkin to write acceptance tests.
I love it. Everyone give them a round of applause. That was really awesome. They just come up with that on the fly. I had no idea that was going to happen.
That's totally a surprise.
Yeah, I'm totally surprised right now. Okay. So that demo I published right here. You can grab that link, or we'll send the slides out afterward. You can grab the link. If I encourage you to look over it, make changes, do what you need to do in order to understand it. But that's the basic of it. So one thing I'll say is, like, there's a lot of different flows to this, but the one that I particularly like is when your product managers, they define a feature, they will actually create a branch. You know, Linear gives you that branch name, so your project managers will have to know a little bit of Git, and then they will create that Gherkin, and then they will save that, and they will check that into the source code management feature. So then the developer, when they pick up the ticket, they'll already have a feature branch created. They can pull that down, you know, merge main in. They will try to compile that Gherkin. Sometimes it works perfectly like it did in the test demo. Sometimes you'll have to generate some steps, and I showed you that in the code. And then you write code to pass the test. What I really like about this is that the intent of the project manager is very explicit, right? Like I know exactly what they want. There's none of the problems that come with pros, because the pros may be lying to me about what Dane wants, but this can't lie to me, right? So I will say that this is very much an advanced testing concept. And I've seen it fail a lot of times. When people do get it right, it works great, but people get it wrong a lot, right? This is not a magic bullet. I think probably one of the biggest problems I see with this sort of approach in the wild is just over-reliance. People think if they're doing this Gherkin BDD thing, they don't need any other kind of test. I'm here to tell you there's a lot of things Gherkin just can't do. It's not really good at non-functional requirements. It's horrid at specifying concurrency, dynamic behaviors. It's not so great for GUI look and feel. Sometimes you can hack it to do these things, but I don't know why you would, right? There's much easier ways to do these sort of tests. So if you think you can just grab Gherkin or Cucumber and run off to the races and forget everything else, you are sorely mistaken. This is an addition, not a replacement. The other big problem I see with this is a lot of times you really need technical project managers to write Gherkin, right? It's not like really complex code or anything like that, but they have to kind of understand the concept of steps and how they run in executions and some basic stuff like that. Obviously, Clayton figured it out really quickly, right? Like just by watching this presentation. I think that at wavelength in particular, I'm not real worried about it, right? I think you got really, really sharp project managers. I think you could pull this off. But the other thing is, if you, a lot of times when I see it really fail is when you have people who are being forced to write Gherkin who would just rather be writing code. The advantage of Gherkin is this natural language syntax. If everybody already understands the code, there's no reason to put another layer of abstraction in there. You understand what I'm saying? So like, this is definitely extra complexity. If everyone can read, is very adept at code, and you don't need that documentation to send to them, there's really no point in doing this. Does that make sense? This really shines when you got people who are technical enough to write the Gherkin, but don't want to write normal code. Does that make sense? But if you can get past all of these common pitfalls, I've seen some pretty amazing stuff with this, right? Like, in particular, if you go out and you look at the Fitness project, which was written by Uncle Bob, FITNESS. So this is another BDD framework that I think is simply amazing, except it mainly works on Java, and no one likes Java. But other than that, that is a remake of a tool called Fit. When you see this stuff in action, it's pretty impressive. So if you want to learn more about this, I highly recommend this Cucumber book. I will say, like, the bulk of everything you're going to see on Cucumber is aimed at Java. And then the non-Java stuff is like .NET or Ruby using RSpec for .NET, and then Ruby is using the original sort of Gherkin syntax and behave and all that kind of stuff. But these are still good references for you. Software engineering at Google does not specifically mention this type of testing, but the way they describe testing is very much in line with this. So that is everything I have for you. Questions, comments? And I stopped with 1 minute to spare. I feel pretty happy about that. No questions at all? If there's no questions, I'll assume everyone is an expert.
How much time, when you've seen this used, I guess, how much overhead time have you seen it take to basically set up the Gherkin syntax for the product managers?
How long does it take them to write the syntax, or how long does it take to get the system in place?
I guess, so before, Dana or Clayton would use Gherkin, one of the developers back right, hey, when I say, given I'm logged onto a web page, I have an async function that goes to that web page type of thing. I guess, how long have you seen that overhead be of developers writing code to make the Gherkin syntax for the PMs, if that makes sense? Does it usually take a while, or does it take like?
So basically,
10
it's usually the other way around though. So typically they write some sort of Gherkin syntax. And when you go to compile it as a developer, you'll see, I don't have these steps defined, and then you have to define the steps. Right?
Yeah.
So I think getting this system, the hardest part is probably getting everyone to use Git effectively. That could be a real issue. There's other tools that you can do stuff like you know, that will do some of that for you, but I find they're usually much more trouble than they're worth. I think the big problem is a lot of times you'll get they will write Gherkin that's really hard to program. Like one time they'll say, I need to go to the web page, and the other time it says I am on the web page, and you end up getting a lot of duplicated steps, which tends to be very time consuming, right? Yeah, I don't know if that answers your question or not, but I'll say like getting this set up is not a small task. Does that answer your question, or did I just make you more confused?
My question, yeah.
Would you use it, Dale?
What's that?
Would you use it?
Is the question, would I use it?
Yeah, I mean, like, would you recommend that we do the test this way, or is this like one of those things where it's like an academic exercise? It's really interesting for like simple applications, but like for really complicated dynamic systems, this might be more trouble than it's worth than just have a testing team of human beings go through it.
That's a really good question. I'll say, like, I did this, to be completely transparent, I've probably tried this 10 times in my career and succeeded twice. One time was moderate success, but the time that I did work right was pretty impressive. We built, it's actually the largest loan management system in the United States, using this sort of Gherkin syntax, and it worked beautifully because everyone was really bought into this concept and everyone was excited about it. So I think that's really the gauge that I would decide whether I want to use this or not. If you have project managers who just really don't want to do this, or you have coders who don't see the value in it, right? It's not going to work. Would it work at wavelength? I think there's definitely a use case for this in Swarm. You got a good base, right? And you got technical project managers. You have all of the components you need to make this work. Would I do it before you get to production? Definitely not, right? But I think it would be a great sort of advanced testing scenario to work on down the line. Does that answer your question? I know there was a little bit of fancy footwork in there, but
I guess the other question I would have is like, when you've done it successfully, I mean, the promise of this is that you don't need the human being to go through and do the full, like, acceptance test, right? Like, you can automate it. Like, did you guys manage to automate 100% of the acceptance test, or there's something still that like you put in, like a human being still had to go through and touch it? I see the shape, no, so.
no, I've heard people talk about 100% automated testing. I've never seen it, right? Like, or I'll say, like, I've never seen it effectively. I think I've seen people, I remember at TCG Player, I'm almost ashamed to admit that I worked there, but anyway, at TCG Player, they had 100% automated testing, but they had website failures all the time, right? Like, everyone thinks they have 100% automated testing, but there's always something that Gherkin's not going to do that you're not going to be able to specify. For instance, let me give you the case, like, suppose you have a website that has a splash screen, right? The splash screen goes for a second and then it goes away, and that splash screen is just a div that hides the rest of the page. If you're running Gherkin, you will say, you will just select the components on the page by name. So you may not even know that that screen is hidden from the user.
Yeah.
I found this out the hard way, actually. So is it 100% automated? No, but I think that's not a failure of Gherkin. I think that's a failure of physics. Like, this is just how it is. I don't know. Does that answer your question?
I'm trying to think like the equivalent of like when they test cell phones, like to make sure a touchscreen works, they have a robot that like taps the screen like a million times to make sure that like it will survive a million times. Like, you almost want that for software, like go to the UI, like move the mouse here, click, move here, like almost like Java robot, but more, right? Like more big features and I mean, looking for very specific things, but what you really want is someone to intelligently interpret the UI to say, this is actually what I expect to see, and that's called a human being. And we have those, we can use them, right? So that, I feel like it goes full circle, right? Like you want to automate it all and you realize there are things that you can't have it do. So then you're like, well, human beings should do it, and the question becomes, well, maybe a human being should do all of it, right? And then on it goes.
Yeah, I mean, I think it's a great tool, and I think, as I said in the presentation, the point of UI testing is to get you to 99%. I think this will get you to 99.5. Right? Like, I think it's a fallacy to think that because something isn't 100% effective, that it's not useful. So yeah, I see a lot of, I think the bigger advantage you'll get from this is like, just to use an almost facile example, I guess, is like, suppose Dane looked at that expression parser and he was wondering about some corner case, right? Instead of having to type that in, he could actually go create Gherkin for all these corner cases that he's worried about, and then now they're executable, right? You don't have to worry about the regressions or anything like that. It's also really good to allow somebody like Dane or Clayton to write a bunch of tests that are already defined to generate documentation without having to even talk to a developer. I think that's the good thing you get out of here. But on the other hand, there is also tons of situations where the Gherkin just gets unbelievably complex, right? Like, say you're worried about some, okay, let's talk about Swarm. How would you write the Gherkin for getting to the last submit page? Right? You may end up having to say, I go to the web page, I enter all of these values, then I click the next button, then I enter these values, then I click the next button, then I enter these values, then I click the next button, right? So pros and cons. I'm babbling at this point. I don't think I'm even making sense. So. Any more questions?
You mentioned that if this is going to work, we need buy-in. Which definition of buy-in are we using today?
Yeah, we're using the I'm gonna just come right out and say the canonical definition of buy-in that hasn't been perverted. Right? Like, so by buy-in, I specifically mean everyone is excited about doing it. Good catch though, Clayton. I like that.
Dale, do you see any issue with buying in and the high turnover rate that comes along with the DoD?
Well, yeah, I think that's like a whole other issue, right? But yeah, that's 100% a problem. I don't know what you do when you got a bunch of people who are excited about Gherkin, and then it gets handed off to a bunch of people who would just rather not be doing it. I don't think that's a failure of Gherkin. I think that's a failure of humans, right? Like, I know what it's like. I have more than once been handed an application using a tech stack that I find just soul crushing, right? Like, they made every technology decision purposely just to shorten my lifespan. It's happened to me, right? Like, I guess I don't really know what you do about that. The only thing I do know about that, though, is the more automated test you have, the more documentation you have that cannot lie to you, the better off you are with a lot of turnover. Like, think about it. If you were coming onto a project, Dane, you'd never heard of Gherkin, how useful would this be to you?
I don't know enough to know
Yeah.
that right answer, but like you said, documentation that doesn't lie is, or doesn't get upsold, may or may not be unique, or is more unique than it should be.
Yeah. What do you think, Jamie? How useful would it be to you if you walked into a project that had all of this Gherkin defined?
I think like understanding how they're using it is probably the most important thing. Like, how does it make me more effective as a product manager?
Mhm.
So understanding like how it affects the team is probably the first step to understanding that.
All right, anything, I know we're over. I don't want to keep you guys too long. Taz, are you ready to scream woohoo?
I think so.
All right. All right, if you learned something, woohoo at the top of your lungs.
Woohoo. Yeah. Obviously, I
There you
learned
go.
a lot today.
Everyone give Taz a round of applause. All right, well, if there's nothing else, I know I'm 13 minutes over. Go ahead and reach out to me on Slack, or you know how to get a hold of me. I really appreciate all your guys' attention today. And special thanks to Clayton and Ian for taking care of that demo for us.
So, thank you.